Hello, this is Grizzly Maximus bringing you part 2 of the 2D dynamic lighting system tutorial. In part 1, we were able to create this, and here we could add lights here, and we could add lights at the back of the wall, here, everywhere, and it would work. It will cast shadows, it would cause lights to blend together, and we can add as much as 2,000, 3,000, 4,000, 5,000 lights. We can have 5,000 lights and it will still be at 60 frames per second. Now in this tutorial, we are going to be learning how to apply these lights to the game. Because right now, all we have are these very bright lights, but we want to be illuminating the walls, we want to be casting shadows, and then we're going to be seeing all the little tiny problems that you're going to experience while doing this. Before we begin, I have added these tile walls. So we see here in the tile set, we have these tile walls. This is the wall tiles and this is the back wall tiles. Now I have also added some auto tiling in these things. We can add these guys very easily. If you want to learn more about auto tiling, there are many YouTube videos, many YouTube tutorials about that. Just search it up. I'm sure you're going to find them. Anyways, now that we know about these guys, we are going to be going to our room editor. And in our room editor, we are going to be adding some tiles. So we're going to be adding a tile here, and this tile will be over the instance layer just as it is right now. Now we're going to be making this the wall tile. Now the wall tile, we're going to be going to the libraries here in the room editor, and we're going to be clicking auto tile, and then we're going to start putting some walls right here in this blue area. Now we can increase this to 2 so then we can do this faster, so we can add lots of walls like so, just like that. Now that we have these walls, we're going to be adding the back wall. Now to add the back wall, we just do the same thing. We add another tiles, and then in these tiles we move this lower below these 2 instance layers. We're going to be setting these tiles to the back wall, and then we do the same thing in the room editor. We go to libraries, we cast auto tile, and then we can draw wherever we want. Let's just make our brush size 4 so it's easy for us. Just do this. Now we're done. So now that we have these, we're going to be running the game. So here in the game, we will see that our light source is just going over the walls. We have this very bright light here. Now, if this bright light goes on top of these black areas, it still remains. What we want to be doing is that we want to make sure that these black areas are not going to be affected by the light. Before we're going to be doing that, we are going to be doing some alternative ways of blocking the light. So last time I did this thing called the Z depth sorting method. Now we can actually do something else. Instead of using the Z depth sorting system, we are going to be using blend modes. Now blend modes, it's actually a faster method to do this. First of all, let's just remove everything to do with the Z buffer. So we're going to be removing these uniform variables. So remove these guys. We're going to be removing this Z test enable, Z right enable. We're also going to be removing this guy here. We can remove this comment if we want to. We'll remove this uniform set shader uniform. Remove that. We remove this iteration. We remove these guys here, and then we go to the create function. We can also remove these Z and Z2. Remove that. There we go. Now we're not yet done. We just go to the shaders and we go to the shader light. Make sure we're in the vertex shader. You see this uniform float UZ. Remove that. We go drag this. There we go. We move this, make it 0 dot. And then we're going to go to this UZ over here. Remove this UZ in the shadow shader. And then we're going to be removing this UZ minus 0.5, make it 0 dot. And we are basically done. We've removed everything to do with Z buffer. So now we go back to the object setup. Obviously, now that we removed the Z buffer, we need to replace it with something else, or else it's not going to work. So what we're going to be doing is that we're going to be using the GPU's blend mode. So we say GPU set blend mode extension set alpha. Now this is a special kind of blend mode function. This one has 4 parameters. The first 2 will be the source color multiplier, then the destination color, and then we have the source alpha, and then we have the destination alpha. So we are going to be saying BM0, BM1, BM1, and then BM0. Now this might not make much sense for you right now, but what this does is that these first 2 parameters here, it ensures that the surface remains the same because we're saying that the source is going to be multiplied by 0. So nothing new is going to be added. And then we're going to be preserving the surface by saying the destination, which is the surface, is going to be multiplied by 1. But what do these two lines do? Well, this does the complete opposite. We are going to be disregarding the alpha values of the destination, and then we're going to be replacing it with the source. Here's the thing. The alpha values, you don't see the alpha values. It's just like the Z buffer. Remember the Z buffer? We actually drew our shadows invisible, but there's a Z buffer value which was placed onto the surface. So instead of using the Z buffer to be storing our shadows, we're now using the alpha. In order for this to work, we need to set this shader shadow. We'll go to the fragment shader of the shadow, and we're going to change this from 0 to 1. But it's basically a white opaque shadow. It's white. Why are we making it white? Now, don't worry, because like I said, even though it's white, we are multiplying this with BM0. So it means that the white thing will just become black. And then we want to make the shadow have an opacity of 1, an alpha to 1. So wherever the shadow is going to be on the surface, that's where the alpha is going to be equal to 1. Whereas everything else, that's where it's going to be 0. Now, knowing that the shadows area is alpha equals to 1, and then everything else equal to 0, that means that we want to be drawing our light wherever the alpha is equal to 0. So we're going to be using this GPU blend mode. We're going to be replacing this with extension separation alpha. Again, just like the one above. We're going to be still making some additive blend, but with a twist. So the first parameter will be BM inverse destination alpha, then BM1, BM0, and then BM0. Now, what does this mean? Well, the first one, this first parameter, is where the magic happens. This beam inverse destination alpha means that wherever the alpha is 0 in the destination, that's where there's no shadow, that's where we're going to be drawing our light. And then we say BM1, which means that we are actually preserving the destination. We're keeping the destination, but we're adding on top of that the light source. So it's additive. And then for the alpha, we set it both to BM0. Now, the reason why we're doing this is because we want to be resetting the surface. We want to be resetting the surface's alpha while still keeping the RGB values. Now, the next time we're going to be drawing the shadows, the previous shadows do not affect. So that's why we're trying to reset to the 0. Now, we also need to make sure that when we first start with our first shadow, that everything has been initialized to 0. So in order for us to do that, we need to say draw clear alpha. This is outside the loop. And we're going to be saying here, we're going to say C black. Now it doesn't have to be black, but we'll just make it black. C black, and we'll make it 0. So the important part here is the alpha is equal to 0. So if we're going to be running this, we are going to be seeing exactly the same results. We have a working light, so we can put lights here, lights here, lights here. It works. Shadows being casted. Now wait. If you're observant, you will notice that the back walls are gone. Why are they gone? Well, the reason why they are gone is because we have added this draw clear alpha. This draw clear alpha has erased the back wall. So how are we going to be putting these back walls back in? Well, we are actually going to be drawing this entire lights and shadows onto a separate surface. And then we're going to be drawing the surface back to the main surface, which is the application surface. So in order for us to do that, we first have to initialize the surface. So we say shad surf. This is what we're going to be calling our shadow surface. It's a variable, and we're going to just say no one. We're going to be setting it to no one for now because we don't have to initialize it in the create. Now we go to the step function, no, the draw function rather, and then we put it over here. We make an if statement here. If surface exists, and we say shad surf. So we make an if statement here, but we have to say if it doesn't exist. So put exclamation point in front. If the surface doesn't exist, if shadow surface does not exist, then we're going to say that shadow surface is going to be equals to surface create. So if there's no surface, we create a surface and we say it's going to be the size of 320 by 180. This is the size of the view, just so you know. So if you are going to be implementing this yourself, make sure that you change these 320 by 180, the height, the width and height accordingly, according to your view size. Now that you've done this, we are going to be drawing this entire thing onto one surface, which is the shadow surface. So we're going to be saying surface set target, and we're going to be setting this to shad surf. And then at the bottom, we're going to say surface reset target. Everything within the surface set target and the surface reset target will be drawn on the shad surface. Since we've enabled the blend mode here, and then we enabled another blend mode here, we don't have to enable it to normal, then we set it back again to this. So we can actually move this BM normal, we can move this down here. Actually, no, not too low. Let's put it up here. There we go. Now, after that, we are going to be drawing our surface. So we say draw surface, and we say shad surf, and we draw it at 0, 0. That is at the point where the view is, which is at 0, 0. You'll notice that the shadows are now all gone. Why are they all gone? Well, there is something that we did, and it's this thing, BM0, BM0. This surface has a alpha of 0, and then we set the blend mode to normal. Take note, we set the blend mode to normal, which means that this shad surface is being drawn, but it's completely transparent, and we don't see it. So in order for us to see it, we need to be changing this blend mode. Let's put this blend mode underneath here, so then it can reset back to normal. Make sure you do that. We're going to set it to extension, and we're going to say BM1, BM1. So we draw the light, and here's the problem. The light source, although it's not working, this light is just going on top of the wall. And if we do this, it's going to start illuminating even this blue side here. So what we're going to do is that we're going to be changing this to BM0, and then BM source color. Then we run it. Now it will make sense in a while. So this time, the areas where there's no light is completely in shade. There's nothing unless I put the light source here. So you could see that there's a wall here, but when I put the light away, we don't see the wall. There's also some walls here in this other side here, some back walls. But when the light is not there, it's completely dark. Now, this is so dark. What happens if we want to be adding some kind of dim light that illuminates the whole entire place? Just a very dim light. So then, even though the lights are here, we could kind of still see some of the walls here. Now, in order for us to do that, we are going to be using the alpha of the surface. So we're going to be saying extension. We're going to be saying surface, draw surface extension. So we're going to be just keeping it to the default. So we say 1, X scales 1, Y scales 1, rotation 0, color C white. Then here's what is important, the alpha. We are going to be setting this to 0.8. We're going to be saying shader set, and then we're going to be saying shader shad surf. So that shader does not exist just yet, so we're going to be creating one. So we're going to say create surf shader. There we go. Name it shader shad surf. In the vertex shader, we're going to be leaving it as it is. We're going to go to the fragment shader. Let's just clean things up here. Anyway, so this is the default shader, basically. So like I said, the vcolor.rgb is going to be multiplied by the sample of the RGB, and then the A is also going to be multiplied by the A, but we don't see the alpha. So we're going to be saying that frag, or vec for frag, is equals to this sampled texture here, and then the geofrag color is going to be equals to vcolor multiplied by frag. But we are going to be only be applying this to the RGB. So what we have to do is that we have to separate the RGB and the alpha. So we say vec3, and then we put this guy inside. Make sure that's .rgb. So vcolor.rgb times frag.rgb. Then we're going to be setting this alpha to 1. Wait, not RGB. .a. Oh yeah, by the way, I think I forgot to mention. This vcolor here is actually this guy here. When we say draw surface extension and then we say C white 0.8, that vcolor consists of an RGB value of C white and an alpha of 0.8. Yeah, I should have mentioned that earlier. So this V color here represents that. Represents the C white and represents the 0.8. The 0.8 is this V color dot A. So right now this thing is actually 0.8 multiplied by the surface. Now let's say we are sampling the brightest area where it's going to be equals to 1. Now if we're going to be multiplying 1 by 0.8, that will give us 0.8. That means, let me show you. The shadows is completely dark, it's still completely dark, and then the light source is actually kind of dim. It's not very obvious, but it's pretty much dim. So what we're going to be doing is that we're going to be, since it's 0.8, we want it to be 1. So how do we move 0.8 to 1? We add 0.2, or we add 1, so we say plus 1 minus V color dot A. So this is essentially the inverse of V color dot A, which is 0.2. If this is 0.6, then this is going to be 0.4. Add them together, becomes 1. So this is the mathematical equation to translate the light source. So here we are. Now we see, even though we add lights here and this part here is supposed to be dark, we could kind of see the light, and then we could change the parameters. So if we go back here and we say this is going to be 0.95, we would see that it became even darker, but we still could kind of see it. Now if we make this 1, it becomes completely dark, just like as we have imagined. It becomes completely dark. We want to be changing this back to 0.8. I've noticed there's a little bit of a problem that is happening. Yeah, what is that? Let me take a moment here. Right, the reason why it's doing that is because we forgot to shader reset. We actually moved the shader reset over here. There we go. Then there we go. That's what we wanted to see. Yeah, it's working. Although we still have the problem with the this blue area being illuminated. Now what happened was that this shader reset was over here, so this shad surf was actually being drawn with the others. We didn't reset the shader, that's why. Always remember to reset your shader, or else you get some weird errors happening. So the next problem that we are having is, as I've shown you, the blue area is still being colored. We don't want to color that blue area. Let's say that blue area is the sky. You don't color the sky. We don't put shade in the sky. The sky remains as the sky. We don't want that to be affected. So how do we do that? We are going to be going back to the room, and we are going to be, well, we're not going to be using the background anymore. Because the thing is with the background is that it has an alpha of 1, no matter what. There's no way you can change it, even though we do this, it doesn't work. It just doesn't work. The way to overcome this is that we're going to be making our own background. But in order for us to do that, we need to be manually drawing the application surface. So we have to say application surface draw enable and say false. Because normally GameMaker Studio 2 automatically draws the application surface for you. Remember, we didn't draw the application surface, it just drew itself to the screen. So now we have done that, the application surface is gone. We press F5, we don't see anything, it's complete black. So we are going to draw it ourselves. So we're going to go to post draw, and we're going to be saying, let's move that. We're going to be saying here draw surface, and we're going to be saying application surface at 0, 0. So we draw this and we see the application surface, but hey, wait a minute, why is it so small? Well, that's because our game is 320 by 180, but this screen here, this Windows is 1280 by 720. We need to be scaling this thing properly. So in order for us to scale, we are going to be saying extension, and then we're going to be using the X scale, Y scale. We're going to be saying 4, 4. Now 4, 4 that's for me, because if we multiply 320 by 180 by 4, we end up having 1280 by 720. For you guys, if you have a different ratio between your view size and the window size, you need to have a different numbers here. So we're going to be saying 0, and we're going to say C white, this is the default values, and then we're going to say alpha is equal to 1. So now the entire screen is now covered with the application surface, and it works exactly the way we want it. We see that this whole entire thing is black, so we're going to be changing that black to some kind of color. So we're going to be saying draw draw clear alpha, and we're going to say it to C, let's say C teal, and then we're going to set it to 1, the alpha. So now we have a teal color in the back, and even though we put some colors, we put some lights here, it doesn't affect the teal. So the light doesn't anymore overlap this teal area, this sky, as you might say. And the reason why it doesn't do it, because we are applying the shadows and light onto the application surface. Remember, this teal color is outside the application surface. Now that we have done that, we are going to be doing some properties for the lights. So what happens if we want to have colors for the lights? Or what happens if we want to be resizing our lights dynamically? Well, we can do that. All we have to do is, let's go to object light, and we're going to be adding some variables. So we say variable definitions here at the bottom, and we're going to be adding, let's say we add color. We're going to be adding, size. So we say size. Now here in color, we're going to be setting this type to color. Now I spell things in American style. And here in the color, we're going to be setting, let's say white. So that's the default color for the light, white light. And then for the size, we set it to 32. There we go. Now, we're not yet done. Those are just variables, but they don't do anything just yet. We are going to go to object setup, and then we're going to be creating more uniform variables for the light. So we're going to be putting 2 more here. Actually, we're not going to be doing that. Not for color. Color something else. We're only going to be making 1 uniform. And we're going to be calling this ZZ. If you remember, in our light surface, we have this value called ZZ. Remember this? Remember, the larger the ZZ, the larger the light. So we're going to go back here to object setup. So we say ZZ, and then we just say ZZ. Easy. And then we go to the draw function, and first of all, we say var underscore UZZ is equals to UZZ. And then we go to the light here. We say shader uniform set. We say UZZ is going to be equals to size. Now for the color, we're going to be saying draw rectangle color, and then we're just going to be saying color 4 times here. Color, copy that. Color. Boom. We go back to, let's copy this. We need to be getting because we removed it last time. And by default, we have this in color attribute vector 4. We're going to be copying that. And then we're going to go to our shader light, go to our vertex shader. Let's add that back in color. And then for the varying vector, we're going to be adding another varying vector. We call this varying vector 4. Let me call this call. This is actually V color, but for simplicity, we're just going to be calling it call. So we say call is equals to in color. Easy. So we pass this in color to the call. So this call goes to the varying vector, and this varying vector goes to the fragment shader. And we combine this uniform vector. So instead of a constant float, we're going to call it uniform float ZZ, and we don't have to set it up anymore because the uniform float already has a value that we give it. Let's see if we change the lights. Let's say we change the value of this guy here to 502. Let's see if the size changes. And it does. Look at that. We have now a very big light. Now, let's say we want to be changing the color. Let's say we want to be making this, let's say we make it orange light or some red light. Okay, let's make it red. Something like that. Okay. We now have, okay, that's not very obvious. Or is it not working? Okay, so I'm sorry about that. The reason why it's not working is because we forgot to multiply the call here. We just say call multiplied by that, and it will work. Boom, look at that. Now we have here some colored light. So we have this orange looking light here. Very nice. We can change the color some more. We can change this. Let's say we change this to a blue light. Let's say we change it to blue. Nice blue light. There we go. We can actually go to our room here, and then we go to we add our own light source. So we first go to our instance layer here, and then we drop in a light. Let's say we drop the light right here. Now in this light, we can set the properties. We just go to variables, and then we could edit these variables. So Actually, let's go back to light. By default, let's make it white because that's the default. Okay, and we set this default to 32. Now we go to room 1, and here we change the default to, let's say, blue, and we change it to 512. We see that there's this blue light here, but our mouse light is white light. So we can add white light here while this guy here is blue light. And then for the child, so this moving light, this is a child, we can also go to variable definitions and we can just set whatever color we want. We just press this so we can edit it, and we can change this to, let's say, orange. Set it to, there we go, let's set it to some very strong orange. And then we set this to, let's say, 64. So now we have this light source. Our moving light is orange, this guy here is blue, and then if we add lights here, it becomes white light. You can also do, let's say, let's do one more little funny thing we can do. Or then we're going to be removing it again later. So let's say that the size plus. Okay, so when we add the light source, the size just keeps on blowing up. So we put here, and then we see that the light is blowing up, the size is blowing up. Look at that, look at that. Eventually it's going to illuminate the whole entire place. So yeah, we can do crazy stuff with this thing.
Bye, have a great time.
Now, the last problem that we're going to experience is moving the camera. For obvious reasons, most likely your game is going to have moving camera. And the problem is that we haven't set our lighting system to be working for moving cameras. Let's first create the moving camera. So in order for us to do that, let's go to the step function, and we are going to be creating some moving stuff. Actually, let's go to the create function first. The create event, and say Vx is equal to 0 and Vy is equal to 0. So Vx and Vy is the position of the view. And then we say here that Vy is equals to, in brackets, we say keyboard check key. So we say Vk down, and we say minus, so we copy this code here. And instead of Vk down, we say Vk up. Then we multiply this by 4. Now you might be wondering, and we say plus equals rather. You might be wondering, what am I doing here? What is this code? Well, this is actually the shortcut to moving your camera using the directional buttons. It might look like it looks some very weird code for some of you guys, but actually what happens is that, think about it this way. If we press down, if this is true, then we multiply this, it becomes 1, and we multiply this by 4, so it becomes plus 4. If this is true, it becomes negative 1, multiplied by 4, that becomes negative 4. If these two are true, then it's 1 minus 1, 0. And so we don't do anything because we're pressing up and down at the same time. Vy should not change. And the same thing could be said for Vx. Now, there's one thing we have to still do, and that is to change the view. So we say camera, set view position, and then we say here view camera, let's set this to 0, and then we say this is going to be Vx and Vy. And we run the script, and we should see everything looks like it's working until we move the camera. And what is going on? What is this? What is this? What's going on? Look at that. Now, some of you guys are really confused what's going on. Even I got confused when I first saw that. And the reason why it's doing that is because we did not reset the application surface. You see, usually we color the application surface with some opaque color. We still need to apply some draw clear alpha on the application surface. But where? Where do we do it? Well, we do this in the draw begin. So we say draw clear alpha, and we say C black 0. Now, the reason why we're clearing the alpha in draw begin and not anywhere else is because if you do it in draw, remember that some of our stuff here, like the back, the back wall tiles, will be drawn already. If we do the draw clear alpha on the draw function, we're going to be erasing the tiles here. So we don't want that. So here, we don't erase the tiles. And if we move the directional buttons, it works really well. Now, for us to test this better, we need to be increasing the room size. Let's go back to our room. I think it's being blocked by this guy. So our room is just 320 by 180. So let's say we make it 1920 by 1080. That's actually 1080p if you don't recognize those values. Now that's the room size. our view size is still 320 by 180. And then we're just going to be expanding this wall. So just expand, expand, expand. We see that the walls are there. But hey, what happened here? Why is the shadow just cutting off here? What happened? Well, there's another problem. We could move the camera, but the shadow remains in place. So the reason why it's doing that, let me show you, is because here in the draw function, first of all, we are just drawing the surface. We're drawing this guy on 0, 0. We want to be drawing this at Vx, Vy. So let's do that. Let's draw this at Vx, Vy. Now, okay, so now the shadow's everywhere, but wait a minute. If I put lights here, it just remains where it is. The walls move, but the shadow does not. It just remains in its place. What's happening here? Well, the reason is because this surface doesn't know we're moving. All these values here think that we're still in 0, 0. So we need to be translating every single thing here. What we're going to be doing is we are going to be using matrix multiplication. So we're going to say matrix set. So we say matrix set, and then we say matrix world, and then here we say matrix build. And then in matrix build, we're going to be saying x, y, and z is going to be equals to negative vx, negative vy, 0, rotation 0, rotation 0, 0, x scales 1, y scales 1, z scales 1. And there we go. Now, what's this doing? Well, this matrix is essentially translating and scaling everything that we're drawing. So this x is going to be x minus vx and then minus vy. So we have to make sure that this draw rectangle is at vx, vy as well, because this guy should be where the vx, vy is. So if we say vx, vy and then we say we translate this to negative vx and negative vy, this will bring this rectangle to 0. And then we do this matrix set again, and we do it here after. We matrix build and we set this to 0, 0. So that's the default matrix world. And if we press enter, we would see an error not set before reading it. Right. That's because we forgot to say var vx is equals to vx and var vy is equal to vy. Here we go. Some little technical errors. So we say vx, vy, and oh, right, I forgot. We have to add vx here and add the vy here as well. And then if we run the code, now if we press the directional buttons, the shadow remains where it is. So think about it this way. The shadow, that rectangle, is actually moving with the view. And then when we're trying to draw the surface, remember the surface is being drawn at 0, 0. So we move everything, all the drawing functions, we translate it to negative vx, vy. And there we have it. We're one step closer to having beautiful lighting system. In the next tutorial, I am going to be teaching you how to create soft shadows. And then in a later tutorial, we're going to be doing the wall shadings. And then we're also going to be teaching you how to do the bloom effect. Thank you very much for watching this video. Please like if you like, and don't forget to subscribe if you haven't subscribed yet. And I'll see you in the next tutorial. Goodbye.